All right, let's go ahead and get started. I'm going to get the lights adjusted. Whoop. And there we go. All right, let me go ahead and make this full screen. All right. So everybody, welcome to week 6 of our freshman engineering seminar. I'm sure you all are getting excited for midterms, right? Yeah. Remember, we don't have exams in college. We have celebrations of learning, right? Yeah, I like that term. Real quick, we have our, if you all remember, we have our New River Gorge bridge tour coming up. If anybody's still interested, I think there might still be an open seat or two, but just go back to some of our notes on Blackboard. You can contact Logan Stacks, the SAME ASC president, or Page News. I believe both of their contact informations are in some of the previous lecture notes, and you can go from there. Just always be cognizant of the meeting schedules. Remember, SAME, ASC, and ASME are still meeting this semester. SAME, ASC is meeting on an every other Tuesday schedule, and the mechanicals are meeting every other Monday. Okay. Now, keep in mind, again, we're going to have a quiz made available sometime later today, and it's going to close next Friday at 11 a.m. So, everybody good? Any questions? October 11th, that's right. Okay, so we have what's that? Free lunch. Okay. Yeah, we have an SAME Huntington Post meeting that's going to be taking place on Marshall's campus. Now, it's in Shockey Dining Room, which is in the Memorial Student Center. It's on the 2nd floor. There'll be some folks from like the Army Corps of Engineers and what have you, free lunch and whatnot. So if you've got time within your schedule, it'll be that Tuesday from about 11-ish in the morning till about 1 in the afternoon. So if you have time to stop by, go ahead and do so. I'll have some more details for you next week. All right, everybody good? All right. So a couple words about our main speaker. Our main speaker is Anthony Ferguson. He's an engineer with Marathon Petroleum. He's also a previous graduate of Marshall's engineering program, so he's proof that you can get past all of us crazy professors. Speaking of crazy professors, no, I'm just kidding. Before we have him come up and present, we're going to have another one of our faculty introductions. Our faculty who's going to be introducing himself this week is Professor Jeff Huffman. Going to talk to you a little bit about the world of geotechnical engineering. So everybody, let's give a round of applause for Professor Huffman.
Good afternoon. By the time you graduate, you'll get this right. Good afternoon. Good afternoon. I'm going to do it to you until you graduate. Got to respond. Got to get you woken up here so we can learn a little bit. So I'm Professor Huffman, all kinds of initials and all that kind of good stuff. I'm a fellow in ASC, so I've been heavily involved in ASC for a long time. And my background is in geotechnical engineering. I'm going to spend a few slides here talking about me and my experience in getting here, and then go show you a lot of cool slides about what geotechnical engineering is really about. Because most people say geoengineering, geotechnical engineering, what in the world is this? It's a subdiscipline of civil engineering. So I'm a civil engineer. I have a civil engineering bachelor's degree, and all my graduate work is in civil engineering, but my emphasis is geotechnical engineering. Dr. Michelson's transportation, I'm sure he's told you. And so all of us faculty have a specialty. Transportation. Oh, structures. He wishes he was no, he's structures. He's structures. He's structures. I get them all confused. They all look the same to me. They're not geotech. All right. There's my email address. Every last one of you can email me anytime you day or night you want to. I'll answer emails at 2 o'clock in the morning if I'm up. So you can email me anytime, anywhere. My office actually is still in the original lab building. I do have an office in the new building, but I don't occupy it. I stay out in the original building because that's where my labs are at, so it makes it easy for me to get to my labs when things are going on. I'm actually from St. Albans, West Virginia. Was born in South Charleston, did most of my life in St. Albans. Went to school, got out. I've lived in Pennsylvania, Virginia, Tennessee, North Carolina. Don't be scared in your life to venture out. Everybody has this thing, I want to stay close to home. I want to stay close to where mom and dad is. Go out and experience what it's like out there. If you want to come back later, that's fine. But get out and see what it's like out there. There's a lot of variety out there, a lot of opportunities out there. I currently live in Tays Valley, almost halfway to Charleston. Been married for 27 and a half years. I know that's longer than most of you have been alive. But I'm lucky to have who I have at home. I have one son, Sam. He's actually a polymer engineer. So he deals with plastics and the manufacturing of plastics and things of that nature. And I got one dog named Lucky. He's a multi-poo mix. So I love dogs, love animals, and that kind of thing. So I received my bachelor's degree from Virginia Tech, 1988. Continued on, worked on a master's degree in civil engineering inside of geotechnical engineering, and currently still working on my dissertation. Kind of stepped away from school for a while and getting back into it. I look at the strength of soil, how strong soil is. I don't know how to grow crops worth a bean. Don't know anything about that. I know how the strength of it is. I know how strong it is, how tall we can put it, how steep we can place it, and things of that nature. So I'm doing a lot of work on the deformation and strength of deep fills that are 100 feet, 200 feet tall, things of that nature. I'm a professional engineer. Got my license in Pennsylvania originally, but I'm also licensed in the state of West Virginia, Kentucky, Ohio, and North Carolina. So those are all states that I've lived in. Those are all states that I've designed something in those states and have used my stamp in the process. So I've been doing this for a long time. I worked 22 years in industry first before I came back to academics. Ran engineering firms, large engineering firms, ran firms in multiple locations. Been still doing that part-time as I'm here. Work about 3 months of a year total, all during the calendar year as an engineer, still doing design work on things. And things that I like to work on and have worked on, I like to work on earth dams, slope stability, retaining walls, do a lot of work on retaining walls, deep and shallow foundations, deep soil fills, and scoreboards. Kind of got a little niche in scoreboards. Do a lot of expert witness work for lawsuits. They want somebody that can talk intelligently in front of a courtroom, know all the details and technical issues on geotechnical engineering, so I do a lot of lawsuit work. And I love doing research and development of new products. I've actually helped develop products that reinforce soil and concrete in my research days. I've made bags out of plastic, out of polypropylene fibers that dissolve once they get wet. New technology there. I've been doing a lot of work on Yeager. Everybody's probably seen and heard about Yeager's slide they had up there. I've been investigating that on and off since it's occurred. I'm actually going up there on Monday, review the site and see what the conditions are up there. And like I mentioned before, I do a lot of work on deep fills. Soil, when you stack it up very, very deep, behaves very, very differently than when it's only 10 or 15 feet deep. Its properties and how it behaves is much, much different. A lot of people don't understand that, and that's where a lot of lawsuits can come from. What I teach, I'm a geotechnical engineer. What goes along with geotechnical engineering a lot of times is materials, concrete, steel, things of that nature. So I teach the civil engineering materials course. It's a civil engineering course, of course. That's a junior level course that's required, so you pass through that course if you keep going on in civil engineering. I teach the geotechnical engineering course, junior level course. Teach the foundation engineering design course. That's an elective, so you take that if you really like foundations in geotech and slope stability. I'm responsible for the Capstone 1 and the Capstone 2 experience. The Capstone 1 experience is not very rigorous, but we start talking about designing your senior capstone project, whatever that might be, in the fall, and then the Capstone 2 is in the spring, and you actually design something that's civil based. And here again, I'm in charge of the whole program. Dr. Michelson, Dr. Nichols, Dr. Wade, all the rest of them are involved with that too because of their specialties, and they're involved in it, but I'm the one that's in charge of it. Things I have taught the CAD lab portion of geomatics. I have taught Intro to CAD, and I have taught engineering computations. I'm not teaching any of those currently right now nor next semester. I'll be sticking with the top 5 you see up there, which is what I like, because that's what I really, really know. I'm real good with senior capstone because I've designed a lot of projects. I've been the responsible engineer of multi-million-dollar projects, so I know what it's like. I can lead you through that experience really good. And the rest of the things are in my wheelhouse. They're about foundations, geotechnical, and materials of civil engineering, which I know a lot about. So I've got a real good niche of courses that I teach here at Marshall. Other things about me, what I'm involved with around here, I'm the chair of the Marshall University Grade Appeal. So if you have a grade that you're wanting to appeal against a faculty member, Eventually, if you keep appealing it, it will come to my desk, and I'll help you solve that issue about whether you can have your grade changed like you might want it to or not. I'm on the scholarship committee for the civil engineering area. I've been faculty advisor of the year for the student chapter. Did that for 6 years. I've been the past faculty advisor. I'm no longer that person. Dr. Michaels is the advisor now, but I'm still a co-advisor and close in there. I've been past president of the West Virginia section of ASCE. Get involved in organizations. Get involved in organizations. It'll benefit you tremendously. I've been a past board member of the American Society of Military Engineers, and there's all kinds of other things I could put on there, and the list goes on and on. Be involved. Get involved. That networking opportunity, you can't comprehend as you sit right here how valuable it is. How valuable it is. You can figure anything out or find anything out. You can find your first job that way. You can find your third job that way. You never know what you'll be able to find through a network, and you got to start establishing it before you actually need it. So, geotechnical engineering. Geotechnical engineering is a branch of civil engineering that deals with the analysis and design and construction of a foundation underneath a building, a bridge, something of that nature, a slope. You've all gone down the interstate and saw those big cuts on the side of the road going up where the road was cut through the mountain. You know, I can figure out how steep those can be for safety. Retaining wall structures, everybody's probably seen the big wall down there at Walmart in Barbersville. It's holding up the parking lot. That's a pretty good sized retaining wall. There's retaining walls all over the place. If it's not taller than me, I don't have anything to do with it. A wall that's as short as I am is inherently stable and won't have a problem. But when they start getting 10, 20, or 100 feet tall, there's a lot of analysis that goes into that. Dams, I've worked on dozens of dams in my day, embankments, be they for retaining soil or just a roadway embankment. Roadway embankment is to support the road. Levees along the roads, have done a little tunnel work, roads, landfills, anything that deals with or is supported by the soil. Supported by the soil. Now when it comes to rock and bedrock, I know I know a good bit about that, but that's not my expertise. My expertise is in the soil and have a good base of knowledge in the geology realm of things. So ultimately we deal with the strength, compressibility, and permeability of the soil. One of those three areas is always an issue on every project. Don't want the water to flow through the soil, so I need low permeability soil. I'm going to put heavy loads like tanks or something on the ground surface. That can cause it to settle up to 2 feet. No one wants their tank or a building settling 2 feet. And we look at the strength. That's the slope stability, or how big the foundation needs to be for the building so that it doesn't settle, have cracking issues and things of that nature. So some cool things. The rest of this is all photographs, so hopefully you guys can click along. Anybody recognize what that is? You're not going to tell me you haven't been to at least one football game, right? It's a stadium, right? The scoreboard's a stadium. That scoreboard stands up because of me. I did the foundation system for that scoreboard. So if you get into civil and you get into mechanical and you get into these things and designing stuff, you can walk around later on in life and say, I did that. If it ever falls over, I'm leaving the country, right? Middle of football game crashes in the field, you won't find me. I'll be out of the country hidden. I'll grow a beard and long hair and all kinds of good stuff. But you can look around and you can see things like this, that, hey, I did this. I've done that. I've done that. And you can see the impact you made on people. And that's what engineering is. It's about helping people out and solving problems. If you don't like solving problems, you need to find a different field. Because the only time they call an engineer is when they have a problem. If they can figure it out, they don't need you. They don't need you. So it's about solving problems. It's about accepting people's problems. Anybody recognize that building? It's kind of a rendition kind of thing. That's the new Weisberg Applied Engineering Complex, correct? That was a rendition of what it was supposed to look like, and I think they came off pretty close to building it. But you see these little concrete shafts coming out of the bottom of it? That's actually the foundation pattern that's underneath the building. We took 18-inch to 30-inch diameter shafts, drilled them in the ground 60 feet. And that's what holds the building up. If we didn't do that, that building would probably settle at about 9 inches. So instead of stepping up into the building, you'd be stepping down into it. Nobody wants to do that, right? So that's a deep foundation system. That's the kind of thing that geotechs design, how big those need to be, how deep they need to be to support the building. Things I work on, I try to prevent these things from happening. Slope stability, this is over in Ohio, on one of the roads in Ohio, and everybody's out there gawking at it, trying to figure out why this happened. Ended up as a water issue. Water was coming off the bridge, concentrating. I got a pointer here, somewhere on here. Right in that corner right there, all the water, the entire bridge came off in that corner right there, saturated the soil, caused the failure to occur. Other slope stability, I do a lot of slope stability work, a lot of failure work. This is a road that's been having problems for a long time. You see they've been patching it and patching it and patching it. And finally it's given way to the point where they're actually going to do something about fixing it. Some of them can get pretty big. I actually was supposed to have a drill rig sitting right there overnight. The drill rig was late getting there. Thank heavens it was late getting there. $500,000 would have rolled down over the hill with the hillside. So major, of course it shuts the road down, major inconvenience. About somewhere in about $200,000, $250,000 to fix that when it's all said and done. So it can get expensive. I like to work on dams. I do work on concrete dams. That's Seeger's Dam up in Pennsylvania. A lot of slope stability issues there. There's actually an old dam underwater right here. Instead of fixing the old one, it was cheaper to build them a new one. So we just buried the old one underwater. Buried the old one underwater. Retaining walls, a multitude of different retaining walls out there supporting parking lots and buildings and all kinds of things. This is a wall like you might see on a bridge approach. It's actually a bridge going to get off that deck you see there. Be a future bridge right there. That's a mechanically stabilized earth wall. There's soil inside there. And we know how to design that so that soil surface, that face can be straight up and down. Can be straight up and down and support all the loads that are on top of it. Another example of a retaining wall, these are anchors. These go back in the ground about 100 feet. And all those anchors are required to help hold that up because that is quite a large height there. Oops. One of the great failures of the world, the Leaning Tower of Pisa, that's a geotechnical problem. They built it on top of a formation that has half the building has soft soil under it, half the building doesn't. So it keeps wanting to tilt to one side. Tilt to one side. And if you actually look at it, you can kind of see, especially like, see how this side looks like it's taller than that side there? See how, what they end up doing is they built on it a couple of years and waited 10 years. And so then when it tilted, they built one side longer or taller than the other side to get it back level again. And it tilted some more. And they built one side longer. And ended up they were actually putting more weight on the side that they didn't want the weight on and made the problem even worse because they didn't understand geotechnical engineering at the time. They've now put some support underneath that, some deep foundations, and it's not going to keep tilting anymore. Because you see it's a curved shape. See it's a curved shape as they've done that. Retaining walls. This is a poorly designed concrete wall that fell over in somebody's backyard. Of course, anybody starts wanting to sue each other. The contractor or the engineer, all that kind of good stuff. It's not always super catastrophic, but I still wouldn't want my house looking like that, would I? Still wouldn't want my house looking like that. And that's the kind of stuff we can prevent, or if we don't know what we're doing, occurs. We can have major events, liquefaction and things like that due to earthquakes. The soil underneath those buildings actually became liquefied. Quicksand. Some of them just settled straight in the ground. A few of them laid over during the event. Sinkholes. That's one heck of a way to come home at the end of the day, isn't it? That's a pretty good size hole. You got to understand karst topography when you're building in it and know how to prepare a house not to have that happen to it. That's Yeager. The Yeager landslide. If you looked at this, got a tape measure out and you stood down here and you measured all the way up to the top up here, about 400 feet. About 400 feet. Largest reinforced soil slope in the world. It's now the largest failure in the world. There'll never be another one built this big. The current next biggest one's 140 feet tall. This was 240 feet tall when it was built. So they'll never build one that large again. And currently right now, all that material's gone down to about right here. Down to about right here. And hopefully in about 2 weeks it'll all be gone. It'll all be gone. More of a close-up shot. Here again, the scale is kind of hard to appreciate in these photos. That's about 150 feet right there. Straight up and down. Straight up and down. That's the end of the runway right there. That's the end of the runway off the airport. Out there, I was the first person to walk on that. 6 days later, out there walking, it was still moving. This material right in here, actually, over the next year, ended up being about 150 feet down the hill because it kept failing over time and oozing down. We called it melting, essentially. It's kind of melting down the hillside. So you can get involved in a lot of cool stuff. A lot of cool stuff in geotech. A lot of cool stuff from a failure standpoint. Because when people don't know what they're doing, don't do it right, it causes problems. So, is there any questions I can answer for anybody right now? Yes, sir.
So
Nice and loud.
you said you'd be leaving the country. So like if one of your structures did fail, you'd be sued?
Typically, what the entity that gets sued is the company that you work for. Now, I'll feel guilty and bad and all that kind of good stuff. But you do not typically get sued personally for anything. It's the company that gets sued. Now, if I did something that was very negligent, then yes, I can be personally held liable for that. But you've got to do something very incompetent. So if you're a good engineer and you're watching what you're doing, that won't be a problem. Won't be a problem. I don't know personally anybody that's ever been sued for negligence. Been in this 29 years, 28 years. I don't know anybody that's been sued for negligence ever. Good question. Anybody else? Anybody? Yes, sir.
On the slide with the karst topography, you mentioned it was up to geotechnical engineering to prevent that. Do you just study the soil and advise them not to build there, or is there something you can do to the house to prevent the accident?
It could be one or the other. Could be one or the other. So we'll go in and we'll drill holes in the ground. First, we have to have a knowledge of geology. There's no karst topography in our general region right here in West Virginia. Get over in Kentucky, you can get it. Of course, you get down south, you get it a lot. Florida and those type of environments. So we got to know the geology in the area. Know, hey, I could have karst topography here. You drill your holes and figure out how the topography looks deep in the ground at the rock surface. And if we do encounter karst topography, we can put the building on deep foundation system, or we can take all the soil off and fix the hole that all that went down into. We can fix the hole and put the fill back in place and then build on top of it and you'll be fine. I've actually built ponds on top of karst topography, but we had to dig it all the way down to the top of rock. It looked like some kind of moonscape. It was the craziest looking thing in the world. And then we built material in there, fabric and grid and things like that, and brought it back up to the surface and then put a nice clay layer on the top. And it's actually Hershey Medical Center has a pond that's on a karst topography. So there's way around anything. It's how much money you got in your hands. You can do anything. It's just how much money you got. Anybody else? Yes?
Do you think the leaning tower Pisa will ever fall?
Nope, not now, because they went in and they've actually put in those foundations that we've got under the Weisberg building. They put a small diameter version of those underneath of it. So it will never tilt anymore. Because it was actually getting to the point of it was getting ready to fall over. It was getting ready to fall over. So they've actually done it. Was about 10 years ago now. They went in and kind of lifted it up, so it'll stay there forever now. Well, I'm going to stick around. I don't want to take all Anthony's time. I'm going to stick around. Afterwards, anybody's got any additional questions, you can come down front and ask me those. You can always email me if you're interested in geotech or civil at all. If you're interested in mechanical or electrical or something like that, I'm not the person you want to talk to because I'm not well versed in those things. So thanks for your time.
All right, just real quick, I'm going to go ahead and hand this over to Anthony, but I had to take a minute and say this. When I was in grad school, I had the opportunity to go to Italy, and I actually visited the Leaning Tower. I just have to say this. It was really short. I expected it to be a lot taller, but it really wasn't very tall. I just sort of stood there and went, huh, that's it. All right, that's all I got. All right, with that, I turn it over to our main speakers. Everybody, let's give a round of applause for Mr. Ferguson.
Pause.
We'll find out. I'll turn it on full screen. Try it now. Zip.
We're good. Well, This is at least the third year that I've done this, and I really enjoy coming back and talking to future engineers and maybe run people out of engineering altogether. I don't know, but I do like coming back and talking to the freshman class, or maybe even some sophomores or juniors that are backing up and taking this class. Just a little introduction about myself. I'm originally from Kentucky, born and raised Ashland. Went to Paul Blazer High School. Went to Marshall here. Got my first undergrad degree in about 2005 in business, and decided that I could do better than that, and came back to engineering school, graduated from here, and I've been at Marathon now for a little over 8 years. And my job there is, I've had several different jobs, and we'll go through those here in a minute, but right now I'm a project manager in the major projects group at the plant. So enough about me. We'll talk about Marathon. And these next slides, Marathon's pretty strict on what we can share, so they're kind of the corporate overview slides. We're been in business over 125 years. We're now the third largest refiner in the United States. Last year we were the fourth. I don't remember who we overtook, but now we are number 3. And geographically and strategically aligned operations. Basically what that means is we're a Midwest refiner. We don't have anything out west. We're on the East Coast and the Gulf Coast. We have several different parts to our business. So we have the refining section, we have the transportation section, so we got a lot of trucks, a lot of pipelines, a lot of boats, and we have the retail section, which is Speedway. All the Speedway stores are owned and operated by Marathon, and then the Marathon stations are actually what we call jobber locations. They're basically franchises. They pay us a fee so they can fly our flag, fly our banner, our logo, and they sole source our product. We are, let's see here, a Fortune 50 company. Like I said, established in 1887, so we've been around a long time. Largest in the Midwest. Everybody wants to know how much money do you make. Our revenues, before we take anything out for your taxes and operating expenses, is $72.3 billion, which is a huge number. And then our net income is, last year, was $2.85 billion. So we made a lot of money, but we also paid $9.6 billion in taxes. So as you can see, we paid 3 times the amount of taxes as we made an income. Everybody can gripe and moan and complain about what gas prices are, but we're not robbing you guys blind. We have approximately 45,000, a little over 45,000 employees throughout the company. Our headquarters is in Findlay, Ohio. It's about 3.5 hours north and a little bit west of here. 2,770 Speedway locations. We just, in the past 2 years, bought the Wilco Hess franchise, added to our station count, and there's 5,400 Marathon stations on the East Coast. We were, at the beginning of this year, ranked as Forbes' best large employer, so that was a big honor for us. We didn't go out seeking that. I guess there was some online polls, and Forbes reaches out to all the different large corporations, does polls of its employees, and our employees nominated us, and a larger portion than any other company, so we were ranked as the best large employer. Like I said, I've been there 8 years, and it really is a good company to work for. And once the mechanical program here gets started, I've heard the rumor of the co-op program maybe getting started here. That would be an excellent way for you guys to maybe end up working for us one day. Another just kind of a corporate slide here: health and safety, environmental stewardship, integrity, corporate citizenship, and an inclusive culture. That's kind of the 5 pillars of our company. This is a very busy slide, but this shows you where all the pipelines are that we own, either own or have an interest in. It's about 8,400 miles of crude and refined product pipelines, so that's a whole lot of pipeline in the ground. We have 7 refineries, and we'll talk about those here in a minute. The closest one right over here in Caltexburg, where I'm based out of. We own 1 biodiesel plant in Cincinnati. I have not. That's the only plant I haven't been to, but it's pretty close. And with the fuel efficiency standards and the renewable fuel standards that are coming out, it just makes business sense for us to own both a biodiesel plant and have interest in several ethanol plants. I guess let's see here. You can see the what's the red dots. I think the red dots are terminals. And I have a brother. He works on the barges. We ship barges up and down the Ohio, the Mississippi, and even in the Gulf Coast and the Atlantic. Like I said, lots of more information, all basically the same. Shows our pipelines. The loop is down here in the Gulf. That's actually in a offshore loading facility, so we can import crude from out of the country and get it into our refining network. So what's it take to get? This slide basically tells you what we do with crude, what products we make. Our crude throughput is 1.7 million. Let's see here. M's and B's don't mean the same all the time, so it's 1.7 million gallons a day of crude goes through our refining network. In a gallon of crude, in a barrel of crude, there's 42 gallons, so it's a bunch of gallons. We also buy 177,000 barrels a day of other feedstocks. Gets to the 1919, and I did the math here. It doesn't make sense, and I have an explanation as to why. It actually, when you add the 1711 and the 177, you only get 1,888, but there is 31,000 barrels a day of just what we call volumetric expansion. So whenever you boil the crude, crack the hydrocarbons apart, you actually get more out of a barrel of crude than what you put in. So we also purchase 412,000 barrels a day of other items off the market and resell it. And at the end of the day, we have 35 billion gallons of sellable product that come through our refineries throughout the year. Refining, like I say, we are the largest refiner east of the Mississippi. These are our 7 refinery systems. Garyville, Louisiana, it's kind of our, we kind of call it our mothership. It's the shining star. It's actually the newest refinery in the nation. Galveston Bay, we purchased about 4 years ago from BP. Catlettsburg, where I work, 273,000 barrels a day. Robinson, Illinois, Detroit, Michigan, Canton, and Texas City. We're actually undergoing a large major project at the Galveston Bay refinery. The Texas City and Galveston Bay are actually right across the street from each other, so we're going through right now and combining those two to operate them as one large refinery. And this shows basically the locations of where the refineries are. Catlettsburg, you can see where's that thing? Where's the pointer? Not doing anything. Well, Catlettsburg's just right across the street from us. Basically, you drive down west on I-64 and get to Kentucky, left and right-hand side of the road. There it is. The only refinery I haven't been to is Detroit, and I just try to stay out of Detroit. It's a pretty rough neck of the woods. Let's see here. I'll tell you a little bit about Catlettsburg. 273,000 barrels a day of crude oil. I didn't do the math to tell you, hey, it's 273,000 times 42. That's how many gallons a day of crude that we put through the refinery. It goes through the crude unit first, and basically crude unit is just a big heater. It boils it, and then in the columns it separates it out. The light stuff comes off the top. Heavy stuff like your pitch, asphalts comes off the bottom. Then you send it through different other units like the FCC or hydrocracker or the hydrotreater units, alky units. Lots of all these. I'm not a chemical engineer. I just work there. Lots of these. If I had a chemical guy available, I would have brought with me. And like I said, we own. There's 3 renewable fuel. Well, there's a biodiesel plant and then a couple of ethanol plants that we have ownership or equity interest in. And to tell you how a refinery is organized, you have the tech service. Those are your chemical engineers, your unit process engineers. Those are the guys that actually optimize the unit, work with operators and product control folks to say, well, today the market is we need more gasoline than diesel, or we need more jet fuel than diesel, kerosene, whatever it may be, we have the ability to ramp up or slow down the process units to make the right fuel. On the engineering side, which is where I hired in several years ago, I hired in as a area team engineer. And the refinery is broken up into several different area teams, and each area team has a mechanical, electrical, or a civil, a process engineer, your operations folks, environmental. And any projects that go on, anything that we need to do, if it's a unit revamp or a turnaround is what we call them, so every 5-7 years units have to come down for maintenance. Those engineers kind of run the day-to-day stuff. Production and operations, the guys that are actually over the hourly folks that run the plant, those are always chemical engineers. They come out, usually you go from tech service to operations, product control, and then maybe plant manager is kind of the career path for the chemical engineers. Maintenance, on the maintenance side, of course, you get hundreds of thousands of miles of pipe and thousands of pieces of equipment inside the refinery. You have to maintain those. So the maintenance planners and supervisors, reliability engineers, those are usually your mechanical and electrical engineers. Econ and planning, chemical engineers again. The tech service engineers will eventually make their way to the econ and planning. Major projects like what I do, normally in major projects, we kind of have a dollar figure. If a project is going to cost X dollars to implement, that's when it comes to one of us. And right now that threshold is about $10 million, so I won't be involved with a project until it gets to about a $10 million total install cost. And then you've always got your accounting, purchasing, IT, HR, and we have a large lab there as well. One funny thing I always like to mention is not a lot of people in engineering think that you always think that you need to do just engineering, but our HR manager is actually a civil engineer. He's a West Point graduate, and I don't know how he got the HR manager, but he went up through the HR ranks and ended up being the HR manager here at our refinery. And this is basically just talks about our major project group. It's made up of several chemical engineers, a couple mechanicals. I'm the only civil engineer in that group, and one electrical. Like I said, it's $10 million threshold is what we touch. We actually have the largest project at the plant right now. I'm the project manager on. We're developing a new sensor control building. We currently operate the refinery out of 5 decentralized control rooms. We're actually going to bring them into one control room, kind of outside the plant, outside any blast circles. It's a safer place for the employees to be, and should improve the efficiency of the organization. So if you're coming down westbound I-64, there's a large dirt moving operation on your right-hand side. That's mine. We're moving about 500,000 cubic yards of dirt. Got a lot of cut, fill, we'll blast some rock. It's for a civil guy, we don't get to experience that usually inside the plant. Ours is usually buried. You know, we put piles in for new pieces of equipment or something like that, but this is the first big civil job that we've had in a long time. Typical day in the life of a project manager. I spend a lot of time in meetings, a lot of time. All of our engineering detail design is done by contractors. I have engineering contractors in Houston, in Baton Rouge, Greenville, South Carolina, close. I have some in Ashland, Louisville, Kentucky. So it depends on what the project is, what skill set, specialized skill set that we need. If it's a large unit revamp, there's not really any engineering firms here that can handle that. But we usually default down to the big engineering firms like a Jacobs or a Shaw in the Houston or Baton Rouge area, because that's where most of the refineries in the nation are. I do get to spend a lot of time traveling, a lot of time going to fabrication shops, a lot of time in engineering firms' offices. So it's a really, I really enjoy this job. It's a job I've wanted since I came there. Not to diminish what the area team guys do, but the nickel and dime, let's put a pressure transmitter in here, let's put a thermometer over here. It's just not very enjoyable to me. These big projects where you can see, you know, we bring in the 1,100-ton cranes like what's sitting there. Those are the jobs that I really enjoy. The area project engineers, they do a whole host of stuff. They're usually
extremely busy. I know I had 35, 40 projects in any one phase of development, whether it's conceptual idea or we're implementing it out in the field. Those guys stay extremely busy all the time. They help the process engineers troubleshoot mechanical issues with equipment or instrumentation. And they do a whole host of things. And these are your mechanical, electrical, and civil engineers. We actually have a couple, well, at least one other engineer, Julie Phelps. Yeah, Julie Phelps, she's an area engineer right now. She's pretty sharp. So she graduated from here a couple years ago as well. Tech service engineers, I won't spend a whole lot of time on these guys. These are the chemical engineers. They're assigned to a particular technology, whether that's alkylation or the crude units or the SDA, which is solvent deasphalter. They're assigned to those particular technologies and kind of become an expert in those. So there's no chemical, unless there is there a potential chemical engineer in here that's going to transfer out maybe after a year or two, go to WU or something? I guess not. We won't spend any time on there. I guess if I had any advice for maybe some folks going through here, the engineering econ, I know it's not an exciting class, but I use that a lot to justify our projects. Work with tech service engineers. Everything in a corporate environment is what's the return, how's this going to make the shareholders happy? Basically, we want to make money for the shareholders. That's why we're in business. We're not in business to give people jobs. That's the unfortunate part of life. But engineering econ, public speaking, I've given presentations. Major projects groups, I've given presentations to board of directors, president of the company. I mean, it doesn't matter how many times you do it, you still get nervous. So the more you can practice it, coming out of college, the better you'll be. Really, I think that's the project management, of course. I think they still offer the project management class here. That's an extremely important class. It was for me, and I would venture to guess any engineer would benefit from that class. So those are the three classes I would recommend taking. I mean, of course, you've got your statics, dynamics, all that stuff's important. But really, for a job like what I have, those are the three classes that I use the most of. I don't get down into the details. I'm not doing design work. I think I can count on my hand how many times I actually did load calculations inside when I was an area engineer, and definitely not now. The jobs are just too large to do that. So, you guys got any questions? I don't care at all to answer anything you want to know.
How many engineers do they actually have down at the plant in Duffy here?
So there are close to 900 people employed there, and I think there's almost 300 salary, and I would venture to guess that 90% of those are engineers, the salaried folks. A bunch. A lot of chemical engineers, about 60% chemical engineers, the other 40% are electrical, mechanical. We do have a couple of oddball material science type guys in our inspection department, but mostly a lot of mechanicals, couple electricals, and we do have a fairly good representation in the civil side here at Caltexburg.
Any questions? All right. First off, anything around the floor? These engineers are taking time out of their day to come and present to you all today, and whatnot, so we greatly appreciate that. Again, a few final notes. Don't forget, you have your, we're going to have a quiz posted sometime later today. It'll be due next week at 11. And also, going to what I said earlier, you all are getting close to midterm, so good luck on all of that. That's all we got. I'll see y'all next week. Y'all have a good weekend.